Welcome to Engage Math, Lesson 3, Problem 1. And we are going to solve inequalities and we're going to graph them. So let's start off with this first one. And we're going to use all of the skills you have from solving equations to solve this. So if we look at this first problem, we know we have to subtract 2x from both sides, or if you want, you could subtract the 7x from both sides. I personally like to get the variables on the left. So we're going to rewrite this as 5x minus 4, and then now the 2x's cancel, and we have less than 16. Okay, so no problem there, but now let's add the 4 to both sides. All right, so when we do that, we now have 5x, the negative 4 and the 4 cancel, so we now have 5x is less than 20. Divide both sides by 5, and x is less than 4. So then on our number line, we're going to put a little open circle at 4. The reason it's an open circle instead of like colored in is because we don't want to include the value of 4. X is less than 4. It's not less than or equal to 4. So all we're going to do now is shade this way. And remember, all the shaded points represent all the answers that would make that inequality true. Any value shaded would work in the original inequality. Okay, let's go to the next one. So this time we have negative 3x, we're distributing, plus 15. Don't forget that negative 3 distributes to both terms, and that's less than 30. So now we're going to subtract 15 from both sides again, and we now have negative 3x on the left, because the 15s are gone, is less than 30 minus 15, which is 15. So I'm just going to rewrite that up here. Negative 3x is less than 15. Now, the one big difference between equations and inequalities is first, we always have to graph inequalities to show the infinite number of answers that can work when we're solving, if assuming that there are multiple answers. So now the other thing is, let's do this as two separate division symbols. When we divide by a negative, like we're doing here, or multiply both sides of an inequality by a negative, the less than or greater than sign has to flip. So this problem, instead of being x is less than negative 5, it becomes x is greater than negative 5. So here's our negative 5. Once again, it's not or equal to, so I'm leaving that circle open, and all of those points shaded would work in this inequality. Okay, let's go to the next one. So just like equations, I'm a huge fan of getting rid of the fractions first. So I'm going to multiply the whole inequality by 2. Because I'm multiplying through by a positive number, positive 2, I do not have to flip this less than or greater than sign. So we now have 28 is greater than or equal to. When the 2 gets distributed to the 1/2, just as a little reminder, that means 2 times 1/2. You could put the 2 over 1, but when you multiply, you get 2 over 2, which we know is just 1. So right here, we're going to have 28 is greater than or equal to 1x. I'm just going to leave it as x plus 20. You're going to subtract 20 from both sides. And when we do that, remember, we don't have to flip the sign here because we didn't multiply or divide through by a negative. So we now have 8 is greater than or equal to x, which sometimes I like to write it this way. X is less than or equal to 8. It just helps me to kind of see which way to shade. But either way, when you make this a closed-in circle, this time we're closing it in because the colored-in circle means that the value of 8 does work in the inequality because 8 is less than or equal to 8. And now we're going to shade all the values to the left. Anything shaded would work in that original inequality. Okay, the next one. So here, I'm going to begin by just subtracting the 5s from both sides, but I'm not going to show that step. There's a positive 5 on both sides, so what I basically have done is canceled the 5s. Like if you subtract 5 from both sides, what you're left with is 7x is less than or equal to 3x. Just like that, you can simplify. Now we're going to subtract 3x, or I know you can also subtract 7x from both sides. I just, when possible or easy, I like to get the variables on the left, but that's just my preference. 4x is less than or equal to 0. So now I'm going to kind of go up here, and we have 4x is less than or equal to 0. Divide both sides by 4, and x is less than or equal to 0. So this time it's going to be a closed-in circle, and x is less than or equal to that. So we're going to go to the left. All right, let's look at the next one. So before I start, I'm going to combine my like terms. So the 3x minus the 8x gives me 5x minus 1 is greater than or equal to 2x minus 5. All right, I'm going to subtract 2x from both sides, and that's going to give me a negative 7x minus 1 is greater than or equal to negative 5. I'm going to add the 1 to both sides, and so now I have negative 7x is greater than or equal to negative 4. All right, so this is going to be a fraction. So now when we divide both sides by a negative 7 to get x completely alone, we're going to get x, because x is now alone, we have to flip our sign because we divided through by a negative. So x is less than or equal to a positive 4/7. So 4/7 is somewhere between 0 and 1. And if you're not sure about that, please go back to reviewing some of your fraction work to make sure you see why that's going to get plotted right here. You know, it might be an approximation, but I'm going to put it somewhere between the 0 and 1. 4/7 is a little bit more than 1/2, but hard to show on the graph. But this is fine to just do a sketch. And it's a closed circle because 4/7 is included. And so are all the values to the left. Okay, let's go to this next one. Again, I'm going to get rid of the fractions. And this, as you know, is a light bulb problem. So the least common denominator is 12. So now I'm going to distribute that 12 through the entire inequality. So I'll have 12 minus, and I'm going to, as a light bulb problem, I'm just going to go right to saying that that's 3x. If you're not sure why, please go back to some of the earlier lessons where we actually solved equations by multiplying through by the least common denominator. But we have 12 minus 3x is less than or equal to a 4x plus 5. Okay, so I'm going to subtract 4x from both sides again because I like to get the variables on the left. So now we have 12 minus 7x is less than or equal to 5. I'm going to subtract 12 from both sides to get the x's on one side, the numbers on the other. So we now have negative 7x is less than or equal to negative 7. I'm going to rewrite that right here. Negative 7x is less than or equal to negative 7. But we know what's coming next. When we divide both sides by a negative 7, we're going to get x is greater than or equal to a positive 1. So right here at positive 1, we have a solid circle, and we're going to shade to the right. And that's it. Thanks for joining us here today at Engage Math.